Hello, in this video I'm going to show you how to use RStudio in CoCalc. RStudio is an extremely popular application that lets you run R code, terminals, draw plots in a nice integrated environment. And CoCalc is a platform that I started nearly a decade ago, which provides a collaborative data science environment where you can create lots of projects, invite collaborators, and work on code in a wide range of languages using Jupyter Notebooks, LaTeX, and RStudio. So let me show you how that works. So I'm logged into CoCalc and click on Your Projects to see my projects. And then one of my projects is called Demo, just a blank project. And what I'll do, my goal is to run RStudio, and all you have to do is click on Servers and then scroll down, and there's a big button labeled RStudio. So let's click on it, and it explains what RStudio is, and then there's a link, and when you click on the link, it starts an RStudio server running in my CoCalc project, and then it opens another browser tab on RStudio so that we can access the RStudio application. So let's do it. So that just takes a few seconds, and boom, we're in RStudio. Notice the URL at the top of the screen, cocalc.com, then it's the project ID, and then server, RServer. So there you are. And you can see it's working, say, plot iris. And you'll see that over here, move out of your way, you can see a plot of the iris data set where you can do any R stuff that you want to do. And there's also a command line terminal where you can see the project and look at your files if you have any. And of course you can make a file, and you have the full functionality of R there. So notice that this is RStudio version 2023-12.1. And also the version of R that we have is 3.3. Or you can also see that at the top. Okay, so that's how you can use RStudio easily in CoCalc, in a CoCalc project. But that's not the only way to use RStudio on CoCalc. So that's one way. Another way, suppose you have intense computational requirements. So you're not happy with the relatively limited power of a CoCalc project. These CoCalc projects, by default, they're just like a little Docker container in this Kubernetes cluster. You can max out all the resources by clicking upgrade this project or by buying a license. But when you do that, the most you can get is 3 CPUs and 16 gigabytes of RAM and a little bit of disk space. So you really don't have that much room. What if you're going to do a big computational project where you could easily use 128 CPUs, a terabyte of disk space temporarily to store a bunch of data, and a lot of memory, because R is extremely powerful and capable of doing all kinds of amazing computations. So here's what we'll do. We're going to create a compute server, which is a way of making a very powerful machine. And we're going to select the R image, and let's create a compute server that has, say, 32 CPUs. So you can scroll through here to choose your compute server. You can also type CPU:32, and it shows just the options that have 32 CPUs. So let's choose the cheapest one, which is this N2D high CPU 32. Okay. And we can also choose different locations, and I will stick with US East 5. And just for fun, let's make the disk, say, 20 gigabytes, which is more than you can put in a CoCalc project by default, but on a compute server, you can put lots and lots of disk space. And now let's fire up our compute server. Oh, let's do one other thing. Let's set, because we're going to run RStudio on the compute server, and because we don't want to have any annoying SSL error, let's set up our compute server so that it's available at rstudiodemo.cocalc.cloud. Okay, there we are. Now I'm going to click Start Server, And now the compute server is going to get fired up. And while it's starting up, which takes a minute or two, I want to edit the title and the color. So instead of it just being untitled, let's call it our RStudio demo. And you can select any color you want. So let's take like a nice green. And that impacts the color on the side here. And also, if you go to the Explorer and switch here, you can choose the compute server and browse your files directly on the compute server and so on. And that color is represented all over the place. Okay, so we're waiting for the compute server to boot up. If you want to watch the actual boot log, you can click on Serial, and it will show you, it's like looking at the screen of the computer as it's booting up. So just to explain the context, a compute server is a potentially large, powerful virtual machine that you can easily connect to a CoCalc project, spin it up. It augments the resources of the CoCalc project, so you can run notebooks, terminals, etc. on it. But you can also easily run RStudio on a compute server, as long as you select the RStatistics image. So once it's done booting up, let's wait for it. Looks like everything's set. What we'll do is click on this link, and we have to put a token in. Click here to see your token, copy it, paste it in to authenticate, and boom, we're now running RStudio. We're connected directly to the compute server that's running RStudio. It has this domain name, and it's running directly on this very powerful machine with 32 CPUs. Okay, and here we are. Just to confirm the CPU count, let me click on Terminal and type top and click 1, and you can see that we now have 32 CPUs. So this is an extremely powerful machine. And I want to run a little R computation that just illustrates using the full power of 32 CPUs. However, nothing is immediately coming to my mind about how to do that. So I'm going to use generative AI, which is not integrated in RStudio, but is integrated extensively in CoCalc, to write a little snippet of R code, which will use a lot of CPUs at once. And so I'll just make a file demo.r in CoCalc. So the CoCalc has a nice little editor. I'll change it so this code is directly on the RStudio demo compute server. And now let's ask an AI assistant using, say, GPT-4, but you can use any model you want. Please write a short little R program that illustrates parallel computation. I want to run this on a server that has 32 CPUs to illustrate that we can run 32 threads of computation at once and get a significant speed up over a single CPU. Thanks. All right, so let's click the button. A little chat appears on the side, and GPT excitedly decides to come up with some suggestions. So it says to load a couple of packages, create a big vector of random numbers, and then benchmark a couple of different numbers of cores and see what the results are like. Okay, so that's a great idea. And what we're going to do is just take the code it suggested, copy back into this file, and then we'll run it from RStudio. Okay, so copy, paste, and we're going to run it on the compute server. So it's possible these packages aren't installed. If they aren't, we'll install them. And we also, of course, have to load the code from the file demo.r into RStudio, or at least open the file over here. So file, open file, we have demo.r. There it is. Maybe I have to save I have saved the file. For some reason, I'm not seeing it here, so I'll just copy and paste it over here. Okay. Oh, look, package R benchmark required but not installed. Install, yes. Okay, so it installed the package, or it's installing it. That's great. Okay, so now how do we run this? We click the big button labeled run. And there it goes. Error, cannot find function benchmark. So I think that probably there's another package that needs to be installed. So let's install this R benchmark package. So how do you install a package in R? Install dot packages, and then in quotes, R benchmark. There it is. It's now installing that package. And now let's try again. Oops. Oh, I just ran the highlighted thing. So let's run the whole file. And it's doing it, creating a big vector of random numbers. See right there. And I guess it's just taking a little while to do that. We can look in the terminal to see if something's actually going on. No. So I wonder if I have to highlight the entire file and then click run. Ah, yeah, that's what I have to do. Okay, so it's now running, and now let's look in the terminal and see what's happening. So yeah, so R is running the calculation, and we just have to wait and see what happens with our benchmark. So what it's doing is it's running the whole thing on 1 core, 2 cores, 16 cores, and 32 cores, and then presumably it'll do it 10 times each, and then show us the output. So this could take a little while, but let's let it go. And I'm just checking the terminal for a second. I don't want to mess with things too much, but just to note, we have this dedicated compute server that's running, and you can also access it in other ways. For example, you can make a Linux terminal over here in CoCalc and switch it to run on the R machine. And a nice thing about, you can see that this R session thing is running. A nice thing about the terminal is it's collaborative. So you can have another person come along and also use the terminal, and you can each type, and you can also use the AI assistant, and you can put a little chat on the side and chat with each other and so on. So that's kind of a neat feature. Okay, so I really don't know how long this little benchmark that illustrates parallel computation is going to take. The main thing I really wanted to do is see that it's using all 32 CPUs. So I'm going to stop the running calculation and then go up here and just make a version of this that's a lot faster. So instead of 10 to the 8th, let's change it to 10 to the 6th and then try running the whole thing. So we can get a good sense of how long things take. Okay, there we are. That was very quick. So let's try 10 to the 7th, which should take just 10 times longer, I guess. And there it goes. And again, let's check the terminal so we can see if anything's happening. HTOP might be nicer because it shows things by thread. Ah, it's done. Okay, so what happened? So presumably this means that it's a lot faster with multiple cores. I don't know. I'm not a big expert on R, but anyways, hopefully you get the idea. If you're an expert in R and you want to run some code and make it really fast, and you just need a lot of CPU, run RStudio on a compute server. Okay, so that's the demo, and let's just get rid of this compute server. And the point is that there are multiple ways of very easily running RStudio in CoCalc now. One, in a CoCalc project, just click on servers, click on RStudio. Two, if you need more power, create a compute server and then run RStudio directly on that. Okay, thanks a lot, and I'll see you on CoCalc. Bye.